This lesson is about aerobic respiration, and the purpose of this lesson is to explain in detail all the steps involved in aerobic respiration. Our starting point is the energy locked in the glucose molecules in our cells, and really the whole point of respiration is to convert that energy into a form the cell can actually use, which is called ATP. For that reason, I'll be returning to this equation over and over again, because this is the key to what respiration is about. We're trying to convert energy from glucose into the form of ATP. Now, you can think of ATP as little bullets of energy that the cell can use to carry out its functions, or another way I think about it very often is it's like the currency of energy in cells that all cells understand, much the same way as we use, for example, the euro to carry out all our money transactions. Now, since energy is key to what respiration is really about, I just want to give an overview of some of the forms of energy we'll be coming across in this lesson. As I said, energy starts off as glucose, the C6H12O6 molecule. We're trying to get it into ATP, but sometimes throughout the lesson we'll see that the energy is in this intermediate form called NADH. NADH is a molecule, you can think of it as a carrier molecule, or as a type of a shuttle that shuttles energy from one place to another in the cell, and when it finally arrives at its destination, the energy is converted to ATP. If you want to find out more details about these particular molecules like NADH and ATP, I've done a previous lesson on these and the basic chemistry of how these molecules work. So, an overview: there's three basic stages in aerobic respiration, and here they are: glycolysis, the Krebs cycle, and the electron transport chain. The first stage, glycolysis, is what we call an aerobic stage. That means it happens without oxygen, but for the other two stages, oxygen is necessary. If there is no oxygen present, the second stage and the third stage won't actually happen. So let's go through these three stages one at a time. And as I said, the equation above is key. This is to what everything that's happening. So as I go through these three stages, I will keep returning to the main equation to see how we're progressing overall in our conversion of energy from glucose to ATP. So first of all, glycolysis. That word means breaking up sugar, basically. So we're taking the C6H12O6, the glucose molecule, and the first stage really involves breaking that up into two C3 molecules, as we call them. And I'm going to use this color coding, which you might find helpful, hopefully, throughout the lesson. I'm going to use yellow to depict where the energy is at the moment, and we're kind of following the energy through the whole cycle here. So if you keep an eye on the yellow, I'm showing you where the energy is at any particular time. So the energy starts off in the glucose molecule, and that molecule breaks down into two C3 molecules. You don't need to know the exact details of these molecules, apart from the fact that they're C6 gives two C3s. They're called pyruvic acid, but that's as much as you need to know, really. Pyruvic acid, or sometimes they're called pyruvate. So now most of the energy is now in these two molecules. Roughly about 75% of the energy at this stage is in those two molecules. Now some does escape here and here. It escapes here, as you can see, in the form of electrons and protons. And again, if you want to see exactly how they carry energy and how they relate to the whole process, I've done a previous lesson on that as well, on the chemistry of that. But for purposes of this lesson, we just want the basic overview. And what happens is the energy here, we'll start with this one first. That energy is delivered to an ADP molecule and a phosphate molecule, as they're called. And that energy basically goes into the bond here. It joins them up, and it becomes what's called an ATP molecule. That whole process is called phosphorylation, when you add a phosphate to an ADP to make an ATP molecule. So there's the bullet of energy I was talking about. This is the guy that stores the energy in the cell, ATP. So some of the energy goes in there. At this stage, we haven't got much ATP. As I said, the vast majority of the energy is still in the two carbon-3 molecules. Now, some electrons also break free with a proton, which is the H+, and those electrons and proton, you can think of them as energy carriers as well. And when they meet this molecule called NAD+, basically, the energy is used to join up with the H, the proton, and you get a new molecule called NADH. And again, that's the guy I mentioned earlier. If you want more details of this whole process of how NAD plus changes to NADH, I've done a previous video on that. So for now, glycolysis, and that's basically glycolysis done. So just to recap, we started off with a glucose molecule. It broke into two C3 molecules, and also a small amount of energy went into making ATP, and also an amount went into NADH. You'll see in some textbooks they give an exact number of each. For example, you'd be forming 2 ATPs or 2 NADHs, but for now what's important is simply that NADH and ATP are the energy carriers that are formed here. Now, we also need to mention location, of course. Where does all this happen in the cell? It happens in, you can see here, an area called the cytosol. And the cytosol is this area here in between, just in here, the yellow area here in the cell, in between the organelles. So that's the first stage done, glycolysis. So again, the key is to keep following the energy through the cycle. At this stage, most of the energy is in the 2 C3 molecules. We can cross out one of them because everything I say about one molecule will be the same for the other. So to keep things simple, we'll just focus on one C3 molecule, for example this one. And now we're on stage 2. So let's follow the energy again through stage 2 and see where it ends up. We now have energy in the form of a C3 molecule, as I called it earlier, pyruvic acid. We are now entering what's called the Krebs cycle. And maybe mention location first again here before we go any further. Location, if you look at these guys here, these mitochondria, the mitochondria here, mitochondria singular, mitochondria plural, this is where the second stage happens. So the C3 molecules end up inside the mitochondrion in the central area here called the lumen, or as it's sometimes called, the matrix. So we need to be aware of that it's happening in the mitochondria. Now also, no harm to revisit after finishing glycolysis as well. What has happened so far? Well, really all that's happened is that this guy has broken up into 2 C3 molecules, and we've got a little bit of ATP. So using my color coding, I might just say I might just shade in the bottom of it there to say we have a little piece of it, but we haven't got a full supply of ATP yet. We've only managed to create a little. Now, back to the cycle. Energy starts off in the Krebs cycle in the C3 molecule, and what happens next is that breaks down into a C2 molecule, acetyl-CoA or coenzyme A. That's all you need to know about this molecule. And simple sums here, C3 goes to C2, so we've lost the carbon, and that goes off as carbon dioxide. I'm going to use black color coding here for waste products. That's a waste product in your cycle. So the extra carbon has gone off as a CO2. And that's, of course, is the first mention of CO2. So that's our waste product. We've started to mention CO2 now, so that's where that comes in our in our respiration equation. So the waste goes off as CO2, but when the C3 breaks up, some of the energy is released as high energy electrons and a proton again. And we've seen this conversion before, that joins up with an NAD plus molecule to become NADH, which again is the guy who's going to carry the energy to where it's needed. There's still a lot of energy left in the C2 molecule. Now let's see where that ends up. So we keep following the energy. It goes into this cycle called the Krebs cycle, and to explain this, there's already a C4 molecule in the cell, and this C4 joins up with the C2 to become again a C6, which is here. So now the energy is in the C6, and yet again that C6 breaks down into a C5, so we lose a carbon, and yet again that goes off as carbon dioxide. Now also, however, the energy from the C6, some of that energy goes off as 2 high-speed electrons again and a proton to form yet again NADH. Now, following the energy still, keep focused on the main thing, which is the energy. It's now in the C5 molecule. Some of that is given off, yet again, as energy to bring for phosphorylation, as we call it, which brings ADP and a phosphate together to give us ATP. And also, some of that energy is given off as 2 electrons and a proton to give us NADH. NAD plus again joins up with the 2 electrons and the hydrogen, so the energy is locked in that chemical bond again to give us NADH. And you usually get 2 of these in one cycle of the Krebs cycle here. Now, at this stage, the energy is back in the C4 molecule, and now it joins up yet again, of course, with the C2 coming in at this stage again here, and we're back to a C6 molecule, and the whole cycle repeats. And that's basically the Krebs cycle. The cycle keeps repeating, and it keeps dumping off this energy as either NADH or as ATP. And that's basically the second stage. Now, if we keep checking back to our original equation, this is key. At this stage, we have produced more ATP. A lot of it is still locked, however, in the so our ATP is filling up, but a lot is still locked in the actual NADH molecules, which are the carriers, which will shuttle it to its eventual destination. So another thing to mention here is, even though I haven't mentioned oxygen yet, oxygen is key to this stage, because it's the way I often think about it is we're going to generate some waste products at the end, which join up with oxygen to produce water, and so oxygen comes in at the end. Really, we haven't mentioned it yet, but the key thing is, if the oxygen isn't there at the end, the whole thing backs up. And stage 2 here is affected. If the oxygen isn't at the end to take away all the waste products, it's like a traffic jam on the road a few miles ahead. If there's a traffic jam, all the traffic is backed up back to where you are in the traffic, in the line of traffic. It's the same here. If there's no oxygen at the end, this Krebs cycle basically can't happen. There's a backlog, and the whole thing doesn't happen without oxygen. So at this stage, maybe we might mention that the oxygen is necessary. So that's where the oxygen comes in the whole respiration equation. Now, so we're on to the final stage. That was the second stage, glycolysis. Now we're on to, so again, following the energy, it's now in the form of NADH. And our ultimate goal, as we keep saying, is to convert it to ATP. So that's what's happening here. Before we start this last stage, just where does it actually happen? It also happens in the mitochondria. Bear in mind, the last stage happened in here in the middle. We're now in what's called the inner membrane, and what happens here is we're going to see electrons jumping through what's called an electron transport chain, and each time they jump, they kind of dump some energy, and that energy gets released as ATP. Now, and let's go through the steps here. So it's a reverse reaction really to the building up of the NADH molecule. So the NADH basically now releases its energy, and it goes back to the NAD plus. And the energy, let's follow the energy again. The energy comes down here. So the 2 electrons now are full of energy from the NADH. And what happens is, if I use my kind of color coding here, they hop along what's called an electron transport chain, which I've denoted by these orange molecules here. And every time it hops along, it sheds some of its energy basically. So we could kind of maybe make that a big circle of energy. By the time the electron gets to here, it has lost some. So I'll just so maybe actually if we just put in if we just show the electron on the way down there, and we can kind of show it losing energy all the time. So it has still got energy, but it's lost a little bit. It has lost more again here. It has lost even more here. And by the time it gets to the end, it has very little energy at all. And that's the idea. Now, when it loses energy, where does it go is the question. And when it loses it, it goes out here, and it meets an ADP and a phosphate, and they join up to make the ATP that we're looking for. And every step of the way, they shed some of their energy along this as they're hopping along this transport chain, and that energy goes into phosphorylation again, and it creates the ATP molecule. So all the way down, we are creating ATP molecules, which is what we're after. And lastly, the energy comes out the other end. I suppose a drain of energy, for want of a better word. It's drain of energy at this stage, so it's of no further use. And the hydrogen, or the proton that we already mentioned up here, this has made its way here, and it joins up with the electron and oxygen. This is where the oxygen is mentioned, I suppose, for the first time really. It joins up with oxygen, and it's released as a waste product, H2O or water. So that's it. That's basically, and we can now go back to our equation for the final time. We have broken up the glucose in the presence of oxygen. So the oxygen is there to as a kind of a valve to release to tidy up here and release the waste products H plus and E when the energy is gone, and take them away as a waste product H2O. So that's the H2O there. We already saw in the Krebs cycle we gave off CO2 as a waste product, and we finally got what we wanted, the energy in the form of ATP. If you look all along here, along the electron transport chain, we have these high energy molecules called ATP, which was the whole point of respiration, to convert energy from glucose into ATP molecules. And that's the end of the lesson on respiration.